Hi, my name is SUBRAMANIAM. I am from 2 BENG S2. So today I am going to explain and present about the lab 1, which is the transfer function and system response. So in this lab there are two systems, which is the mechanical system, which is one, and the electrical network. So you can see from here, this is the figure 1, which is the mechanical system, and the figure 2, which is this one, which is the electrical network. So for figure 1, we can say that the V1 and V2 represent as the coefficient of friction, M1 and M2 represent the mass, while the K1 and K2 represent a spring constant. So for figure 2, in this electrical network, we use mass to solve this transfer function. So we use this one as loop 1 and this one as loop 2 to find out the transfer function for this electrical network. So for the calculation part, so for the first one, part A, we will obtain two main equations, which is the M1 and M2. So this equation will be transformed into matrix forms. From this matrix form, A1 and A2 will be obtained. Then after that, determinant A1 and A2 will be determined. So we will obtain the result, which says G1s equal to XS and X2 determinant. So there will be a two equation for the part A. As for the part B, so as I said before, there are two mesh 1 and mesh 2. So we transfer into matrix form. So we find A2 and we will find a determinant, which is the determinant A and determinant A2, and find the current, which is I2, and find the output voltage, which is the VLS. Then finally we find the transfer function for the second part, which is the electrical network. Hi, now I am going to talk about the result for this lab. As I mentioned, there are two types of parts in this lab, which is the mechanical system and the electrical network. So each part will have one coding, so there will be two coding for this lab. So this first coding is for the mechanical system. So as you can see, firstly we need to declare all the values. For example, it's the M1 equals to 1, K1 equals to 1, FV1 equals to 2, M2 equals to 1, K2 equals to 1, FV2 equals to 1, and FV3 equals to 1. So we declare the value and put the equations. Need to declare all the values, the numerator, denominator value. So after declare and put the correct numerator, denominator, all the correct values, we need to click run. So when you click run, as you can see, there are three figures. So as I mentioned before, for this part there will be two main equations. So this figure 1 represents the first equation, which is F, the amplitude of 1, and the second figure represents the second equation, which is the F around amplitude of 2, and the third figure is the combination of the first equation and second equation. As you can see, this one is amplitude is 1, so you can see the amplitude and in 1, and you can see this one is 2, so the amplitude and in 2. So you can see this is the graphical picture of the two main equations, because M1 and M2. And for next one, which is the part B. So for the part B, which is the electrical network, So we need to declare all the value first, such as R1 1, C1 is to 1, R2 equals to 1, C2 equals to 1, R3 equals to 1, L equals to 1. So we need to declare the two symbols, the correct equation A equals to R1 plus 1, and the A2, and we need to fix the determinant such as the I2. Then we need to make sure the numerator is correct, 110 and 2541. So we need to put the correct and exact value to obtain the graph. So after declaring all the values, so now we need to click run. So this is the step response for this lab, which is you can see the curve W from 0.5 it will like a dam and with 0. So from here we can say that the coding for both the lab is correct and get the expected value that we needed. Thank you.